Hello everyone, back again, Recurrence Relations, Higher Maths. You'll be sad to know that this is the last lesson in the Recurrence Relations topic. So we are going to look at something called long-term effects. Now, this top recurrence relation here, un add 1 equals 0.6 un plus 3, where u0 equals 10. What I'm going to do is I'm just going to use my calculator to cheat and work out what u1 is and u2 and u3, and then we'll just have a wee go at extending that. So remember, to use the calculator, hit 10, hit equals, then times 0.6 plus 3, hit equals. So if you do that on your calculator, you should get that the next term, u1, equals 9. Now all I want you to do is press that equals button a few times and watch what happens to your answers. So you get a couple in the 8s, and then we've got quite a few in the 7s. Keep pressing equals, keep pressing equals. You will find that it's 7.5019, a big long decimal. Keep pressing equals, keep pressing equals, keep pressing equals. And if you press it long enough, you will eventually get to 7.5. Now, once you get to 7.5, keep hitting equals. You will find that it never goes lower than 7.5. This is called the limit of a recurrence relation. Okay? So if you keep this recurrence relation going, the answer will always be 7.5. It is known as the limit. Now the recurrence relation underneath it, 3un plus 2, where u0 is 300. I'm going to try the same thing on this. So I'm going to hit 300, hit equals, times by 3, add 2, hit equals. Now if you keep pressing equals, all that you'll find is the number just gets bigger and bigger and bigger and bigger and bigger. That is because for a recurrence relation to have a limit, this number in here has to be between -1 and 1. Otherwise, it just gets bigger and bigger and bigger and bigger. To link it into something that's happening right now, you'll hear the scientists talk a lot about the R number and how it's important to get it under 1. That is because if it's bigger than 1, the answer, or how many people with COVID, just gets bigger and bigger and bigger and bigger. So what I can say is that for a recurrence relation to have a limit, now I'm going to do a wee kind of formula thing here, so remember, a recurrence relation, they all take that form. When we don't have numbers, we've got the A and B there. A limit exists if A is between -1 and 1, and that's how we write is between in fancy grown-up maths. Can't be -1, it can't be +1, it has to be in between. So what you would do is you would look at the A value and you can easily tell that that one is going to have a limit and this one is not going to have a limit. Now what we're going to do is I'm just going to do a proof here to show you what the limit formula is going to be. This is at the point where most people give up and don't like it. But you've got more resilience than that, you're going to keep going. Right, I'm going to take this recurrence relation here. Okay? Now we just found out that in this top recurrence relation, if you keep pressing equals, you keep getting 7.5 as an answer. Now that might be u100, it might be u101, u102, u103, u104, they're all going to be 7.5. So what I can say is that this thing here, for example, u101, and this thing here, for example, u100, they both equal that 7.5. They both equal the limit of the recurrence relation. So watch what I'm going to do. So instead of having un add 1, I'm going to have L, standing for the limit. Then I'm going to have A times the previous term. The previous term was also the limit. Remember that we kept getting 7.5. And then I will have add B. Now what I'm going to try and do here is work out a formula for the limit. So I want the thing to say L equals something. but it can't have an L on this side. That's a problem. So what I'm going to do is I'm going to take this to the other side. It's a positive, so I take it to the other side, it becomes a negative. And all I'm left with on the right hand side is B. Now, because I've got a wonderful mathematical brain, what I'm going to do next is a fancy wee trick to go from having 2 L's just down to 1 L. And I'm going to do some factorising. Remember that? It's been a while. Common factor of L here. So L goes outside the bracket. L times 1 would make that. Take away. L times A would make that. And all of a sudden I'm going from having 2 L's, which is problematic, down to 1, which is good. Because I want this equation to say L equals. So I'm going to now get rid of this. This is multiplying. Remember, a bracket multiplies. If I take that to the other side, it will become a divide. And that, people, is the limit formula for a recurrence relation. L equals B over 1 minus A. Remember that B is this number here, the add or take away bit, and A is this number here, the thing you multiply by. We only have a limit when the A value is between -1 and 1. Okay, we only have a limit if that happens. What we're going to do here is just a couple of questions just to see how you calculate this limit without having to hit equals on your calculator 43 times. So, first question. UN add 1 equals 0.5 UN add 12, U0 equals 20. Find the limit. First thing I'm doing is I'm checking to see if it has a limit. This number has to be between -1 and 1. Okay? I'm going to communicate that to the person that's marking this. I'm going to write down the A is 0.5. I'm going to write down my condition for a limit. So, as A is between -1 and 1, we have a limit. And now I'm going to calculate that limit. So, limit formula. Now, this is one of these formulas that you don't get given in a formula sheet. You just need to memorise it. So, it's B over 1 minus A. So, remember up here, that's your A, that's your B. So, it's 12 over 1 minus 0.5, which is 12 over 0.5. And if you're feeling a wee bit sad, I'll let you use a calculator. Some people might know that dividing by a half is the same as multiplying by 2. The limit of that recurrence relation is 24. So if you keep pressing equals, you get 24 as your answer. Second one. My recurrence relation is UN add 1 equals negative 0.5 add 3, U0 equals 2, find the limit. First thing I need to do is check to see if it has a limit. Well, A is minus 0.5, and as that is between -1 and 1, Houston, we have a limit. Okay, now calculate the limit. So, limit formula, B over 1 minus A, and then fill in the information. So, B is 3. 1 minus A is negative 0.5, so I've got 3 divided by 1 minus negative 0.5 is 1 add 0.5, which will give me, so 3 divided by 1.5, that equals 2. So the limit of that formula is 2. Right, I want you to try question 3. UN add 1 equals 0.9 UN minus 2, where U0 equals 5. Find the limit. One thing I'll tell you right now is it's okay to have a negative limit. Hit pause, on you go. Right, first things first, what is A? It's 0.9, and then what I need is my condition. So as that is between -1 and 1, we have a limit. If you do a limit question in an exam, in an assessment, and you don't write that down, you will lose a mark. We are very harsh. Calculate the limit. Limit formula, B over 1 minus A. So b, it's not just 2, it's minus 2, 1 over 0.9, so that is minus 2 over 0.1, and that should give me minus 20 as my limit. Did you get it right? Of course you did. Right, question 4. Again, I want you to try this one, so I want you to have a look at the question, hit pause and then have a go at it. un add 1 equals negative 0.8 un plus 4, u0 equals 10, you've got to find the limit. Hit pause, on you go. Okay, first things first, what is the a value? It's minus 0.8, and as that is between minus 1 and 1, we have a limit. There we go. First things first, limit formula. B over 1 minus a. Okay, so this time up here b is 4. A is negative 0.8, so that's going to work out to be 1 add 0.8, so 1.8. And then you're going to dive to the calculator. Even I shall use the calculator for this one, and it tells me that my answer is 2 2/9. If you wrote it as 20 over 9, that's fine. If you wrote it as 2.22, shame on you, don't write it as a decimal. Keep it as a fraction, please. Right, so that's how you basically just do a limit. I'm going to show you a question in context, and then I'm going to let you have one attempt at it, and then that is us for recurrence relations. Right, this is a long question. Who thought we were doing English? In a small village, it is estimated that the population drops by 5% each year. A land deal has been arranged to persuade people to return to the village. This results in 15 people returning each year. If the original population was 200 and the population keeps dropping at a steady rate, what is the long-term effect on the population? This long-term effect is a fancy way of asking you for the limit. You've got to watch out for that when you're reading these styles of questions. The first thing we're going to have to do is almost back to the very first lesson. You're going to have to write the recurrence relation for this. You should have had enough practice at this for me to be able to go relatively quickly. So, what's my percentage? It's a 5% drop each year. So if I start at 100%, I take off my 5%, that is 95%, and if I change that to a decimal, it's 0.95. So I go to my recurrence relation, 0.95 is what I'm multiplying by each time, so that's un. And now I'm going to go back into the question and see if I can find out what the add or takeaway bit is. This results in 15 people returning each year. So in terms of how many people live in the village, every year I should add on 15. And then I want to check if they've told me what u0 is. If the original population was 200, u0 equals 200. I have set up my recurrence relation. Full marks so far. Right, now, what is the long-term effect? I need to calculate the limit. Don't forget your little statement. So A is 0.95. As that's between minus 1 and 1, we have a limit. Limit formula, L equals B over 1 minus A. So in my recurrence relation, where are we? There's my A, there's my B. So it's going to be 15 over 1 take away 0.95, which is going to be 15 over 0.05. You dive towards the calculator. 15 divided by 0.05 works out to be 300. Now, because this is a question in context, I cannot just leave my answer as 300. I need to try and relate it back to the question. So the question is about the population of a village. And what we've just worked out is if we keep doing this after year after year after year, we will eventually reach 300 and the population will stay at 300. So you just got to write a wee sentence to try and communicate that to the teacher. Okay? So something like this should do. The long-term effect is that the population, now watch this phrase, will tend to a limit of 300. This is the phrase we're looking for here. It will tend to a limit of 300. Okay, your turn. Have a look at this question. Once a week, the council remove litter from a public park. They remove 90% of the litter present. Each week, the public drop 25 kilograms. In the long run, what will happen to the mass of litter in the park? So, if you want to rewind and look what I did in the last question, on you go. What you need to do is you need to get the recurrence relation, write it out. You then need to calculate the limit, and you need to write a wee sentence at the end. Hit pause, give it a go. Right, first things first, percentage. They remove 90%. So I start at 100%, I take off my 90%, that gives me 10%. I change that to a decimal, which is 0.1. Recurrence relation, un add 1 will equal 0.1 un. Go back into the question and see if I can work out what the add or take away bit is. Each week the public drop 25 kilograms. So in terms of how much litter is in the park, the messy public, it's probably you lot, teenagers, add 25 kilograms. I'm going to have a look in the question and see if I can find out what U0 is. They don't mention an initial value. That's because when the park is first created, there would be no litter in the park. Right, recurrence relation is set. Now we're going to calculate the limit. To get full marks, you need your restatement. So A is 0.1. As that's between -1 and 1, we have a limit. Let's calculate the limit. Formula, remember, this should be imprinted in your brain. B over 1 minus A, back into my recurrence relation. There's my A, there's my B. So it's going to be 25 over 1 minus 0.1, which is 25 over 0.9. You die for the calculator. 25 divided by 0.9 works out to be 27 and 7/9. And I saw it mentioned kilograms. I'm going to put kilograms in my answer. Okay, so now we need to communicate this numerical answer into something that makes sense in terms of our question. In the long run, what will happen to the mass of litter in the park? In the long run, the mass of litter in the park will tend to a limit of 27 and 7/9. So it doesn't matter, every week the council come and remove 90% of the litter, and every week we will eventually have 27 and 7/9 kilogram of litter in the park. How demoralising for the council workers. And there's a little message, folks. Don't drop litter. It's messy. Right, recurrence relations is finished. Hope you enjoyed it. See you next time.